Assalamualaikum. My name is Ribna Arif and today my presentation topic is hyperconjugation. हाइपरकंजुगेशन की बात करें तो ये डिलोकलाइजेशन होती है इलेक्ट्रॉन्स की जिसमें सिग्मा और पाई बॉन्ड इन्वॉल्व होते हैं इन केस ऑफ रेजोनेंस. When carbon possessing at least one hydrogen is attached to another carbon bearing an unshared orbital to an unsaturated carbon, there are more than one structure possible for the molecule. These results from the overlap of the bonding electrons of the CH sigma bond with pi orbital of the adjacent carbon atom, which this will result no bond between the hydrogen and carbon. The shared pair of the electron is now bound by the carbon non and hydrogen is in its close proximity as proton. The negative charge will be developed on the carbon to get delocalized by the overlapping with the orbital. Hyperconjugation no. Resonance, the electron of the sigma bond between C and H are involved in delocalization. In the structure, in the right side, no bond between C and H due to the migration of the sigma bond. Hence, the hyperconjugation is also called no bond resonance. Effects of hyperconjugation on the chemical properties. Alkyl cations and the relative carbocations have an electron deficient positively charged atom carbon. The Mg(p) orbital of this sp2 carbon can overlap with sigma orbital of CH bond of the alkyl group. This overlap permits individual electrons to help the binding with three nucleus, two carbon and one hydrogen. The positive charge thus gets dispersed over large volume of space and is destabilized. The more number of alkyl groups on the carbocation is, then the more number of CH sigma bonds and hence more possibilities of hyperconjugation for the carbocation, which will be the most stable. The order of the stability of carbocation. First one will be 9 hyperconjugation है, second में 6 hyperconjugable और फिर 3 और end पे बिल्कुल भी नहीं है. Alkyl radicals have p orbitals of carbon occupied by an odd electron which gets delocalized by 3 nuclei, which will be 2 carbon and 1 hydrogen. They will overlap and the sigma orbital of CH bonds of the adjacent alkyl group. The bond is formed between 2 carbon and the odd electron is held by the hydrogen atom. इसमें ये जो डायग्राम है इसमें पहले इसमें 3 कार्बन और तीन हाइड्रोजन और 2 कार्बन है जिसपे एक सिग्मा बॉन्ड है और उसके साथ 2 हाइड्रोजन अटैच है. उसके बाद सिग्मा बॉन्ड हाइड्रोजन से अटैच हो गया और ये जो डबल बॉन्ड बना लिया. उसके बाद सिग्मा बॉन्ड हाइड्रोजन के साथ अटैच होके ये पॉजिटिवली चार्ज. The order of stability depends on the extent of delocalization. The greater the delocalization, the more will be the stability. Alkenes and their stability. Overlap of sigma orbitals of CH bond with pi orbital of adjacent CC double bond gives rise to canonical structure. Delocalization of electrons occurs over 3 nuclei and thus stabilizes alkene. इसमें पाई बॉन्ड और सिग्मा बॉन्ड दोनों एक दूसरे से अटैच होके कॉनिकल स्ट्रक्चर बनाएंगे. अल्फा sigma CH possesses partial ionic structure and its electrons gets delocalized into adjacent pi By system mode, the substitutes more is the opportunity for hyperconjugation and is more stable in the alkene. इसमें bond length hyperconjugation leads to shortening of sigma bond. Example CC bond in the 1,3 butadiene and methyl silene is 1.46 in length and is less as compared to 1.54 forming the saturated hydrocarbons. Anomeric effect may the general tendency of anomeric substitution to prefer an axial orientation is called an anomeric effect. इसके example है सिग्मा मिथाइल ग्लूकोसाइड जो कि ज़्यादा स्टेबल है बीटा मिथाइल ग्लूकोसाइड से हाइपरकंजुगेशन की वजह से Baker's methane effect alkyl groups are electron donating the relative magnitude of this inductive effect of alkyl group is जैसे कि वो पहले हमने डायग्राम में देखा कि उसमें 9, 6 और 3 के hyperconjugate ज़्यादा stable है as compared to other. This order is reserved when alkyl group is directly attached to an unsaturated system where the electron release is maximum for CH3 and the order is Baker-Nathan effect was explained by the John W. Baker and V. S. Nathan on the basis of the hyperconjugation. Thank you for your attention.